Today we're going to be working on mapping formal logic. The idea is about when to map and also how to do it. What are these specific steps that allow you to place your variables on your formal logic map with certainty? The idea is that formal logic, also known as conditional causation, is absolute. You're dealing with guarantees. It only is relevant when you can prove something beyond any possible doubt. That allows you to chain logics together. If one variable proves another and that a third, well, you can map things together if you're dealing with certainties. Formal logic, because it's so strong, so powerful, constitutes its own language on the LSAT. It allows you to answer a number of different question types. Formal logic is most relevant for inference questions, but you're also going to find formal logic pop up in parallel reasoning questions, in principal questions, and others as well. Let's dive into examples on how to map formal logic, both sufficient and necessary conditions, and our exact steps for mapping. I have here a number of different formal logic examples. We're going to be working on how to map these and also how to build a contrapositive, which is a translation from a sufficient into a necessary condition or vice versa. So we have an easy one here first. All wine is tasty. All is an indicator here that we're looking at a sufficient condition. We can prove the presence of the effect. So we know with certainty when something is tasty. We don't know when it's not tasty. We don't know when it could be tasty. We know when something is tasty. And what is tasty? What's the condition that with certainty is tasty? Wine. And our contrapositive, remember our math equation is to reverse the variables and reverse the negations, but it should make sense in your head as well. Now, to reverse them, we just put the t on that side, the w on that side, and reverse negations, make them both negative. But this does make sense because if it's not tasty, well, it can't be wine because all wine is tasty. So if it's not tasty, it can't be wine, right? That should make sense in your head. Now, the next one, we're going to have a negative here. I don't know with certainty who is at the club. Could be full of all sorts of different people, but I do know who's not at the club. So we're going to add not at the club right here. Again, line through it to say not. Who's not at the club? Well, academics. So if you're an academic, then you're not at the club. Meaning, if you're at the club, what do I know? I know that you're not an academic as the contrapositive, which makes sense. It is only in Tampa Bay that I can truly relax. Now, this is a hard one. Only is an indicator of a necessary condition. So in this case, I'd like to prove the absence of the effect. I know with certainty when I am not relaxing. A number of people would mistake this and think I am relaxing if I'm in Tampa Bay. That's not what this means. I know if I'm not in Tampa Bay, well, with certainty, I am not relaxing based on this statement. And our contrapositive, if I am relaxing with certainty, I must be in Tampa Bay. It's always raining in Bilby except for Sundays. Now we have always and except. So we can prove the certainty of raining, absolute certainty of raining. And apologies, I do have multiple R's, multiple T's. Keep in mind, these aren't meant to link together. If I was going to chain these relationships, I would use different variables because raining here and relaxation, of course, aren't the same thing. But they're all separate statements, so I'm just using the same variable, the same R. I know with certainty when it is raining. When is it raining? Well, if it's not Sunday. Because if it is Sunday, I don't know for sure it could be raining. But I know if it's not, well, with certainty, it is raining. So if it's not raining, then I know for sure that it must be Sunday. Unless it's Tuesday, Martha is always at the mall. Now you'll note we have an exception and a guarantee here as well. So again, I know when Martha is at the mall. When? If it's not Tuesday. These are the same relationships. 4 and 5 do have a parallel setup. I just switched what side those exceptions are on. Here it's at the end of the statement, here it's at the beginning. But really they mean the same thing. And our contrapositive, well, if she's not at the mall, I know for sure it's got to be Tuesday. This one's a little harder because we have our necessary indicator unless, and here it's actually could. So we don't know with certainty when Bobby is at the restaurant. We can't prove that. Could cannot prove a certainty. But we do know when he's not at the restaurant. When is he not at the restaurant if it's not Thursday? So in this case, it functions exactly the same as number three. Can, could, only unless. And our contrapositive, well, if he is at the restaurant, it must, with certainty, be Thursday. If it's snowing, I must be wearing a snowsuit. This is just straight back to our sufficient example. If it's snowing, then I'm wearing a snowsuit with certainty. Meaning if I'm not wearing a snowsuit, well, it must not be snowing. No one who wears long pants can run as fast as possible. Again, we want to start at the end. What can we prove with certainty? I know when I'm not running as fast as possible. I don't know when I am, but I do know when I'm not. And when am I not running as fast as possible? If I'm wearing long pants. The contrapositive, if I am running as fast, well, I must not be wearing long pants. I'm always happy in New Orleans. I know when I'm happy. When? If I'm in New Orleans. Meaning if I'm not happy, I must not be in New Orleans. And I'm never sad in New Hampshire unless it's raining. In this case, I know when I'm not sad. I know when I'm never sad, in New Hampshire specifically. And that is included in my S. S isn't just sad, S is sad in New Hampshire. And when am I not sad in New Hampshire? Well, I'm not sad in New Hampshire if it's not raining. If it is raining, I don't know, I could be sad. But if it's not raining, I know that I'm never sad. Meaning if I'm sad, it must be raining. These are a number of formal logic statements, examples of how to map, when to map, what constitutes sufficiency and necessity. The idea is that you are proving a relationship with certainty, and you always want to start at the end. What do we know? And then, how do we know that? How can we get there? What's the condition that ends up at that result?